A while back, I was in my local electronics store and I saw a box with a captivating label. Scan Plus, the gray scanner for computer. With a name like that, I had to buy it, even though I figured it was probably exactly what it sounded like. A gray scanner for computer. Obviously. Well, it probably is obvious enough. This is a PC document scanner, and a very old one. I've tracked it to about 1990, 91 at the latest, and typically that wouldn't interest me because a scanner is a scanner, right? Even if this is truly ancient, the only things that are really going to change are the resolution, the speed, and the interface. And from the box, this looks pretty cheap, so maybe it makes an awful picture, takes too long to do it, and it's irritating to hook up. Well, as it turns out, all those things are true, because this was the cheapest scanner on the market when it was sold. It was about $600 at a time when scanners usually cost over $1,200. Now, being bad doesn't really make something interesting if you ask me, but I got this anyway because I had to know what was gray about it and why they felt that was important enough to put in the name. Well, as you might guess, gray just means that it doesn't do color, which is pretty weird to think about from a modern perspective, right? Scanners these days do a ridiculous amount of color. Like most of them are 48 bits per pixel. But per the box, this one can only do black and white, halftones, and grayscale, which are respectively 1 bit, also 1 bit, and 6 bits per pixel. At best, this delivers a whopping 64 shades of gray, and it does at least do so at 300 dots per inch, both vertically and horizontally, and supposedly it can use most of scanner software. So it's not as bad as it could be, but still, it's not color. And when I saw this box, I thought, have I ever actually seen a monochrome scanner before? Well, I had, but only sort of. The first scanner that I ever used was the one my family got in about 1998. It was an AGFA. I hated it, but it was basically just like one you could buy now. It was a flatbed. You put a document on it, you hit scan, and you got an image. It took a very long time, it was very low resolution, and the picture looked awful, but it was still in color. Now, at some later date, I came across an old Logitech Palm scanner in our garage, and I was told that it only scanned in black and white. So I guess I had seen a monochrome scanner before, but I had no idea when that was made, and it was also a pretty weird gadget. Palm scanners only capture like 5 or 6 inches at a time, so I always assumed it was some kind of special purpose device, and not really relevant to the overall development of the field. But on that note, standing there looking at the box, I realized that I knew nothing about the history of scanners, and as it turns out, I'm far from alone. If you want to know where digital cameras come from, for instance, you could just Google that, or check Wikipedia, or check an actual paper encyclopedia. As a kid, I had one printed in 1988 that still had a pretty good timeline with lots of specifics going back to the original CCD experiments at Xerox. And there are whole websites nowadays dedicated to the granular history of these things, down to hundreds of individual models that the vast majority of people don't even know exist. On the other hand, if you Google who invented the scanner, things get bleak. The wiki page, for instance, has a history section which consists of one sentence that says scanners descended from early facsimile machines, and the rest is just irrelevant facts about those that don't even belong on the page. And other websites invariably do the same thing. They describe very early technologies, maybe they mention like early industrial scanners, and then they go, now draw the rest of the owl, and leap directly to the present day. There also don't seem to be any YouTube videos on this subject. People do videos on old printers all the time, but no one has ever made a video about a scanner, except for Tech Tangents, who did a piece on the HP ScanJet 4C, and that one touches on a significant amount of contemporary history. It's actually a terrific video, you should check it out. But other than that one example, nobody else has gone near this subject. I couldn't even find a crappy listicle full of half-truths. There's just nothing out there, and that's probably because scanners are pathologically boring. It's impossible to be interested in them. People can find fascination in printers, for instance, because they're so differentiated. There have been so many approaches to the problem, so much cost cutting and things that never took off or have been completely forgotten. Printers can produce shockingly good or bad results, or use strange media, or print very quickly or incredibly slowly. There's plotters to look at. There's spark printers and high quality dot matrices. There's so much variation. Are printers boring? Absolutely. Can you get interested in them anyway if you're a huge nerd? You bet your ass. Likewise, cameras are documented in great depth because they are creative devices. Their qualities, or lack thereof, have direct impact on what they create. A crappy digital camera can produce a uniquely bad photo, or one that's almost illegible, but that can be fascinating or even desirable. Scanners aren't like that. They can't have a characteristic look that can become a vital part of a work of art, because if they did, everyone would be mad about it. All a scanner is supposed to do is convert something you already have into a digital form, and we all want that process to be totally objective. The only things we care about are quantitative, resolution, color depth, aberrations, and since modern scanners have become virtually perfect in all those regards, there really is nothing from the past that anyone wants to revisit. This is simply a problem we once had and have now solved. This is not a sexy topic, so nobody has bothered to write down anywhere that I can find the answers to my questions. Were scanners all black and white once upon a time? And if so, when did that stop? I had to go find this out from primary sources, had to synthesize it myself. It was a lot harder than I anticipated, and the results were pretty surprising. But since this thing is what got me interested in the first place, I figured I'd show it to you, show you some of the early scanning experience, and then explain how it fits into the history. So let's get this thing unboxed. To my great shock, everything is actually in here as far as I can tell. So we've got the interface card. We'll be taking a look at that later. We've got the original cables. Better hang on to those. Those will be worth something on eBay someday. We've got the original manuals, which are actually pretty extensive. There's quite a lot of documentation in here. And we have the original software discs. Don't worry, I have archived those. And finally, we've got the scanner itself, which there's going to be a lot of styrofoam noise here. Please hold. Ugh. Absolutely awful stuff. Get rid of that. And finally, we've got the scanner itself in this very unfortunate decaying slipcover. We'll set that aside as well. I think we'll have the same experience with or without that. Styrofoam bits. Wonderful. Great for keeping your studio clean. Oh, there's more up there. Oh, terrific. I love styrofoam. This stuff should definitely exist. No, it's in the scanner. I'll still be picking up styrofoam bits 3 weeks from now. So here's the machine at last, and there's not a whole lot to it. The model number is actually Scan Plus Gray 300. And all we have is the paper tray here. We've got a contrast control. We have a feed button. And around on the back, we've got just the data port, the power jack, and the power switch. The included documentation for this thing is actually fairly extensive, and we'll refer back to it a few times throughout this video. But let's just see how Scan Plus introduces us to their product. We thank you for purchasing this grayscale scanner. This product was developed as a team effort to provide the consumer with a sophisticated computer peripheral at an affordable price. Not only does this tell us they didn't just make Bob and accounting do all the work, but just 2 sentences in, they've told us that low cost was at least their number 2 goal, if not number 1. That's not very encouraging. Reading on a bit, we feel our designers and engineers have met these objectives by providing a very compact, sheet-fed, 300 dpi, HP ScanJet Plus compatible grayscale desktop scanner. Well, that sure was a series of very reasonable statements, followed by one that makes no sense in 2024. Keep that name in mind, by the way, HP ScanJet Plus. That's going to come up again. So, putting this aside, there are just some obvious differences right off the bat between this and a typical modern unit. And I'm sure you'll have noticed the biggest one already. It's not a flatbed. This is a sheet feed design, as in you feed sheets of paper into it. And that's not all that remarkable in itself. In fact, these are still quite popular. This, for instance, is a Fujitsu Scan Snap. I use this to scan receipts for my taxes, and you just unfold it here, and you put a whole quarter ream of paper in the top, hit scan, and it'll just pull the whole stack through 1 page at a time. It's fully automatic, which is why these are called auto document feeders, or ADFs. They're incredibly common these days and very convenient. You don't even need a dedicated one. Flatbed scanners often come with ADFs built into the lid. They're wonderful when they don't spindle and mutilate your documents. What makes this one odd is that it's not automatic. It's just a DF. There's no A. You have to feed sheets into it 1 at a time. And I'd never seen that before, except in like cheap little business card scanners, that sort of thing. So this raised another question. Was this approach common once upon a time? Were flatbeds something that came later? We'll put a pin in that. So I want to show you how this thing works, but to get started, I need to install this interface card in a PC. But that's kind of its own topic. Why do we need a dedicated card just to run this scanner? Can't it just plug into one of the PC's ordinary ports? Well, the thing is, PCs didn't really have ports in these days. I know that sounds very silly, but bear with me. Nowadays, we have tons of USBs on everything, and you can hook up just about any device to those, short of a high-performance GPU. But USB didn't appear until about 1996, and for the preceding 15 years, there just wasn't really anything like it. The original PC had no built-in ports whatsoever. Everything was an add-on except the keyboard socket. Of course, serial and parallel cards were pretty much assumptions from the get-go, and by the time the clone market got up to speed, they were getting built into everything, but that's it. Those were the only standard ports the PC ever got, and they were awful. Serial topped out at about 100 kilobytes per second, parallel only around 50, and the PC's ISA bus ran at 5 megabytes per second, so that's about 2 orders of magnitude faster. These were pretty cramped interfaces. And the only real savior was SCSI. It was sort of the USB of its time. Incredibly fast and extremely expandable, and pretty much every high-performance peripheral came in a SCSI version, including scanners. Here's one from the late 80s. They definitely existed. The problem is, SCSI was very expensive and it never really came down in price, so consumers largely couldn't afford it. To give you an idea how bad this was, in 1989, nearly a decade after SCSI came out, at least one vendor was selling scanners that used the PC's serial port, and they took 3 whole minutes to scan a page. This was considered egregiously slow even for the time, but eventually they released an upgrade, an ISA card they called the Enhanced Parallel Interface that dropped scan times to 30 seconds. To be clear though, that's the electrical engineering sense of the term, parallel as opposed to serial signaling. They stressed that the scanner wouldn't work on a normal PC parallel port, so I'm sure that card was a bespoke device solely for that one scanner, much like this one is. That seems outrageous, but they were stuck between incredibly slow and universal ports or an incredibly expensive and rare one, so the only option left was to make something from scratch. ScanJet Plus seems to have reached the same conclusion. This board is very minimal. There's not much on here, just a couple logic gates, a flip-flop, a buffer, a bus transceiver, and a single programmable logic array, or PAL. Take my word for it. This is all very simple stuff. And I'm no good at reverse engineering, but just from the vibes, I'd say we're looking at essentially an ISA bus extender. This PAL chip is probably doing nothing more than address decoding, and then the data lines from the bus probably just get shot down the cable straight to the scanner. In other words, this doesn't do anything. The scanner itself is an ISA device. It's just too big to fit in a PC, so the card extends the slot over a cable. So yeah, things were just barbarian back then and they had to solve problems in silly ways. But hang on a second, because that first scanner I used in 1998 did actually connect to my parallel port, and it worked just fine. In fact, a ton of stuff did back then, like card readers and CD-ROMs. The parallel port got used for all sorts of things. So I was a little confused by this. And it turns out I'd stumbled into a common pitfall when studying the past, the tendency to snap events to decade boundaries. I think of parallel port peripherals as a 90s thing, but at the time this device came out, the parallel port was literally a different interface. Most PCs made after the mid-90s offer 3 modes in the BIOS for the parallel port: SPP, EPP, and ECP. The first one is the original dog-slow IBM PC interface, but the devices I remember using always needed EPP, the Enhanced Parallel Port. And while that's called a mode, as far as I can tell, it seems to be a completely different interface with a totally different pinout that just happened to use the same connector. In any case, it increased parallel port throughput to nearly 2 megabytes per second. That's about 40 times faster and nearly half the throughput of the ISA bus itself. ECP was ostensibly even better, so these modes are the only reason that high-speed parallel peripherals were ever really practical, and neither one existed before 1992. In other words, after 10 years on the market and thousands of hardware developments, the PC's standard interfaces hadn't gotten 1 bit per second faster than what IBM put in their very first machine. I stumble across this fact about twice a year, but I'm astonished every time. It's just so hard to believe. I mean, this is why the PC XT was such a huge success. Despite having almost no improvements over the original machine, it did offer 3 additional slots. And for the first decade of the platform, everything needed its own slot. So, now we know why we need the card, let's go ahead and install it. Now, I should mention before we proceed, my computer here is a bit anachronistic. It's a Dell GM5133 from 1996. That's 5 years newer than the gray scanner for computer, but people hang on to stuff for a really long time, so it's entirely possible these would have been used together. Its Pentium 133 CPU is much faster than anything available in 1991, but trust me, it's still incredibly slow. And it's happy to run DOS and Windows 3, which are the only things the manual covers. Well, actually, it covers Windows 2 also, but that can be really hard to get and keep running. So I went with 3. Give me a second, I'll get this all hooked up. All right, get used to that fan noise for the next 25 to 30 minutes. So I've installed the software that came with this thing, but we're not going to see it right away because it's kind of crappy and it's also only for Windows. We will get to Windows, don't worry, but DOS was still very important at the time, so I'm starting there. Now, the manual actually suggests several different compatible graphics packages and has specific instructions for using each one. It's surprisingly high quality documentation. I ultimately went with PC Paintbrush 4 just because I'd heard that was popular once upon a time. Actually, I heard it was a really big deal for a while. I know it was bundled with a bunch of mice in the mid-80s, since otherwise there wasn't a whole lot of mouse-driven PC software yet. It's also the origin of the once popular PCX image format, and ostensibly it's the basis for the initial versions of Windows Paint, so kind of got all over the place. I haven't messed with it all that much, but it seems fantastic, especially given its age. I was particularly impressed at how clean and usable this interface is. They've essentially recreated the early Mac UI, but entirely inside this one app running under DOS. And this actually introduces a problem. This program predates the Visa BIOS extensions. Some people keep telling me it's pronounced Vesa, but that sounds awful, so I'm not saying it. In short though, because this is older than the VBE, it can only work with graphics cards that it was explicitly designed for. And since it's way too old for my Dell's S3 Trio 64, I'm limited to plain old VGA. That means either 640 by 480 at 16 colors or 320 by 240 at 256 colors. Now, side by side, the increased color depth does look appealing, but 320 is just not enough resolution, especially once you add the menu and the toolbar, so 640 is really the only option. Now, reproducing photos in just 16 colors sucks. It's usually pretty rough to look at, but because we're working in grayscale, we have an advantage. We can go in here and go to Get Palette, and we can replace the default 16 colors with 16 shades of gray. And that's actually surprisingly usable, as you'll see once we scan something. So let's get to that. We're gonna start with this sample document, which is a page ripped out of a calendar. Do you realize how hard it is to find a glossy full-page photo in a store? I was gonna buy a picture frame and just pull out the placeholder, but they're all advertisements now. It sucks. This'll do though. So we insert this into the slot. Well, it would help if I turned it on, wouldn't it? We insert this into the slot, and when it notices it, it grabs it from me, and now we're ready to scan. So we go into the scan menu and we'll go in and take a look at the options. Now, there's a whole bunch of stuff in here. We're going to be going over many of these things later, but first we need to select a color mode. We're going to go with grayscale at 256 colors. Now, the scanner only does 64, but this program doesn't natively support 6-bit images, and upconverting is usually lossless, so what can you do? We'll ignore the rest of this. We're going to leave the resolution at default. Next up, we've got the geometry window. We could crop the image. That'll also be relevant later, but we just want to scan the whole page. So let's make sure our contrast knob is centered, and away we go. Not enough memory for scanning. What? Why? All right, there's our picture, and now you can see why they bothered with the custom interface card. That only took about 30 seconds, which is perfectly reasonable even by modern standards, and that's with delays for buffering. If I decrease the resolution, it'll actually do the whole scan without pausing every couple of seconds. But since we did scan at full resolution, we now have kind of a problem. At 8.5 inches and 300 dpi, this is over 2,500 pixels wide, which is about 4 times wider than our screen. Well, so what, you say? Just zoom out. Yeah, software of this era rarely had arbitrary zoom settings. Often you could zoom in, but only at 1 or 2 fixed increments, and you couldn't zoom out at all. Now, PC Paintbrush does have a zoom out option, but it looks like this. Yeah, it's kind of weird. It's not even actually showing us the entire image, I should point out. It's only about 50% of it. And it's bit crushed to like 4 shades of gray, I'd say, probably because that reduced the memory footprint. That's a point that's going to come up frequently in this video. Get used to it. So there's no way to actually see what we scanned in its entirety unless I save the picture and look at it in another program. But I'll save us some time since I baked a scan before the show. It looks like this. Yeah, it's, well, it's not great, but I don't know if that's a design defect. I'm pretty sure the analog circuitry in this thing is out of whack due to age, because all the pictures I get out of it are horribly distorted. They're streaky, the contrast falls off in one direction, these weird quantized stripes. There's some kind of odd diagonal strobing going on if you zoom in, and it sure looks like there's optical issues too. I think the mechanism might be misaligned somewhere because the right side of every image is actually blurry. So I'm certain this thing was not sold in this condition. Although the manual claims it can get scans that look like this, and I don't believe that either. Manufacturers have never been afraid to sell scanners that just don't work right. For instance, the first time I tried to scan a photo back in about 2002, I got this. Now, I don't remember if the print was any good, so maybe the whole lower left quadrant was stark black to begin with, but it certainly didn't look like corrugated steel up close. This kind of streaking was extremely common in 2000s era scanners, so I imagine the gray scanner for computer was no better, but I'm sure it was never this bad. All the same, we can sort of get an idea what the image would have looked like if we sort of peer between the aberrations, and even where it looks fairly intact, you could tell the quality would never fly nowadays. Each pixel here is getting less than a byte of data, so it just isn't very nuanced. Consider that a scanner from even 20 years ago would capture at least 1 full byte of data per color channel, so 24 bits per pixel. That means the crappiest scanner you've been able to buy for the last couple of decades can still see 16 million different colors. And any actual photo scanner goes even harder. They all do 48-bit color, which can't even be displayed on any monitor in existence. The only purpose of all those extra bits is to make sure all your details get captured, even if you can only retrieve them in post-processing. Here, that's impossible. We'll demonstrate that poorly with this wolf. A friend of mine shot this photo, and it's just so striking. I linked it below so you can see the whole picture. It's a terrific shot, and I have both a good quality print and the original JPEG, so we can compare. All right, there he is, but let's get a closer look here. Let's rotate him, then we'll take the original picture, put that next to it, reduce that to 8-bit grayscale at the same resolution, and now we can compare between them, and you can see how much more detail there is in the original photo, even at the same resolution and even at that low color depth. I mean, you have to read between the analog distortions, but you can still tell the 6-bit color from this scanner looks much less nuanced because it just doesn't have a wide enough range of tones. 8 bits, even in grayscale, offers 256 possible shades, and that's really the minimum for reproducing a photo. With only 64, subtle differences in brightness that don't fit into one of those tones just get swallowed up and merged together. There's no preventing it, and it wouldn't be so bad except that this scanner has no auto exposure feature. The sensor in this thing has very poor dynamic range, so this contrast slider on top is necessary to adjust the preamplification to bring the parts of the image you're interested in into the sensor's gamut. So every time you do a scan, you have to set this slider based on, well, your gut, basically. You just look at the document and go, that looks like about a medium. And then you hit go, and when it's done, you find out whether that was too much or too little. If it's too high or low, whites or blacks will become grays or vice versa, and there's nothing you can do about that after the fact. The damage is done, the image is ruined, and all you can do is adjust the slider a little bit and try again. And it might not even be possible to capture the entire picture. If the range of tones is too wide, you might just need to choose what you're going to lose. So this quality is just unacceptable by the standards of today, but it was 33 years ago, so we can cut it some slack, right? Well, I don't know, can we? I mean, were scanners typically this crappy back then? Well, spoiler, I haven't really determined that from my research, but I have a much better question. Did it matter if this was crappy? And it might not have, because first you'd have to ask what exactly you'd have used a scanner like this for. Because even by 91, graphics were just a very new thing for most people. And prior to the ubiquity of color inkjet printers and email, there wasn't a whole lot you could do with a digitized photo, at least as a consumer. You couldn't print it, you couldn't send it to anyone, you couldn't really effectively edit it, and you couldn't even really view it legibly on the average PC. So the only reason you'd really bother with this, generally speaking, is if it was part of your job. But even then, you'd have to really need it. Prior to the mid-90s, computers were just awful at handling raster images, mostly because they took up gobs of disk space and even more memory. Virtually every early magazine article about scanners has a pull quote, or in one case a subtitle, about this problem because it was just the biggest issue with the whole thing. Consider that at full resolution, a single grayscale page from this scanner takes up about 6 megabytes of RAM, and since very few apps would have supported 6-bit color, you'd usually be stuck with the PC paintbrush approach, scanning into an 8-bit canvas, so that's a whole 8 megs. Well, let's take a look at PC Magazine's 386 Roundup from 1990 to see how common that was. That is a year earlier, but very few people ever have state-of-the-art computers, especially back then, so at best you'd probably have one of these. Only half of these shipped with at least 8 megs of RAM. And remember, we still need space for DOS and the app itself, so we actually need more than 8, and that limits us to exactly 2 machines, both of which cost $6,000. And of course, you could upgrade most of these to get more RAM, but you were looking at spending hundreds or thousands of dollars on the prospect, and that's assuming, of course, that you did nothing about the graphics. You could use 640 by 480, but if you were doing any kind of serious publishing work, especially if it was in color, you'd want something better, and the price stacks up even worse. But that begs the question, who was doing publishing work on a PC at that point in time? People love to talk about the desktop publishing revolution that the Mac supposedly ushered in, but the PC absolutely played a role as well. In fact, the Mac may have had an official GUI first, but the PC still had better graphics for most of the 80s, and it always had far more expandability. High-res, high-color depth video cards were available by the middle of the decade at more or less reasonable prices, so graphics work was very much possible on the PC. And Windows obviously contributed to that, but as we've just seen from PC Paintbrush, you didn't need a GUI OS. And in fact, there were even a couple sophisticated publishing packages for DOS as early as 1986. But admittedly, Windows did make a big difference, and people often understate its significance. It was not just a shell for DOS, and that's a point I'd argue to my grave if it weren't just a plain and simple fact. It is, indisputably, an operating system, and we won't get into that, but to wit, its most significant feature when it was introduced was one of the biggest defining qualities of a modern OS. It abstracted the PC's hardware. As I mentioned earlier, DOS apps had to be custom coded for every piece of hardware they supported, so developers of graphics apps had to own every video card their program might be used with. As we can see from the PC Paintbrush setup program, by the late 80s there were hundreds of these, each one with its own unique software interface. The Visa BIOS extensions that I mentioned earlier sort of resolved this around 1994, but until then, if a program didn't explicitly support your card, you got the blue plate special, VGA, EGA, or CGA. And even if you went out and bought a great card that Paintbrush supported, your page layout app also had to support it. I figure this kept the publishing market from growing on the PC for many years. Apple, for their part, solved this by simply not having any hardware expandability. Your software targeted the Mac, and if the user needed better graphics, they couldn't have them. Problem solved. But no, really, this was a big sticky issue, and it was tough to fix. Windows did so by introducing what we now call a hardware abstraction layer, a software middleman which allowed drivers and apps to be developed once, then used together in unlimited combinations without needing to know about each other. A Windows program would work on any graphics card with a Windows driver, and this spurred the development of much more sophisticated software because developers could spend their time writing features instead of hundreds of redundant drivers. Let's see how that affected things. Windows 3 was still widely supported in 1996, so it runs on my Dell at 800 by 600 in 16-bit color, and that offers a lot more elbow room to work in. But ironically, and in complete contradiction of everything I just said, the software that came with this scanner can't take advantage of it. The program is called Picture Publisher, and it was apparently a pretty big deal when it came out, but by 1991 it must have seemed impossibly outdated. It was developed for Windows 2.0, but since Microsoft kept the OS interfaces consistent, it will run on 3, and that's good because it's the only Windows app I have that'll talk to this scanner. Windows didn't have a scanner API yet. It was a work in progress, so you still needed a dedicated piece of software. What can you do? So here it is, and we'll go straight into the scan dialog here. We get pretty much the same options as the other program, they just have different names. So let's put this guy in. We'll just run off a quick scan. You may have noticed that actually didn't have that hitch every couple of seconds. Apparently the Windows software manages the buffering a little bit more efficiently. Anyway, so there's our scan, although you'll just have to take my word for that because for some reason, this app is limited to 1-bit graphics. And I have no idea why. Even Windows 2.0 supported VGA and better with a supported driver, but this program refuses to leverage it. So you can't really make out anything. This is baffling, but I read the manual and it's intended behavior. You aren't actually supposed to use the app in this view. I'm actually supposed to go up here and hit this exchange button. And sure enough, the picture looks a lot more legible now. There's more color depth, but the resolution is god-awful. It seems to be switching the whole display into VGA 256 color mode. I suspect by talking to the graphics card directly, since Windows 3 didn't support on-the-fly resolution changes. So this is how you'd have to do it, I guess, but I don't see why they needed to do it. This is bizarre, and it renders the app essentially useless. You can see your picture in too few colors or too few pixels. Pick one. Now we could, of course, just load this up in another better app, and I'm gonna do that, but I have to save this file first. And it's very weird because it takes like 3 minutes to do so. I can't figure out why this is. I mean, hard drives at the time were pretty slow, but not that slow. And more importantly, PC Paintbrush does it in about 30 seconds. So this may be more efficient at reading from the scanner, but it's apparently much worse at writing to the hard drive, however that works. All right, I saved that, and now we can open up Aldus Photo Styler, a much more modern, much more tolerable piece of software. See, this one's willing to take advantage of my high color graphics card. This program actually loads the entire scan in about 30 seconds, so I know there's nothing wrong with my hard drive speeds. You'll also notice that it actually lets us zoom out so we can see the whole picture. Let's go in here and rotate this thing so we can see a little better. There we go. It seems like PC Paintbrush applies some sort of contrast curve automatically, but this program is apparently showing us exactly what came out of the scanner, so we have to adjust the contrast ourselves. Let's actually try just pulling down the midtones here, see what that looks like. Ooh, that's pretty good. Oh, that's much better. Yeah, let's a little tiny bit less, I think. There we go. I'll go with that. That's good enough. Let's also resize this image because I want to work with it in another program. And 3592 by 2554 is pretty rough. Let's do, 720 by something. That looks a little more reasonable. It appears we also got some white borders. Can we crop this a little bit? There's the crop tool. All right, let's save this. And now let's pop over into our page layout tool. We're going to use Aldus PageMaker, which later became Adobe PageMaker and was, I think, kind of a big deal for a while. We'll just make a single page document and let's get some text here. We'll just go with a README. That's good enough. We're going to spruce up a README file here. Now let's go get our image. The graphics in the linked file would occupy 331 kilobytes in the publication, include complete copy anyway. I don't know what happens if I click no. And it turns out even 750 by something is kind of big, so let's scale that down. There we go, that looks pretty good. And now let's go in and wrap the text around it. And there it is. We've got a finished document. I don't have a printer hooked up, but otherwise that was a PC-based publishing workflow by the standards of 1991. And it's not that different than what we do today, really. That was pretty slick. And the scanner did a bang-up job, ignoring the crappy program we had to use and the crappy quality of the scan. If we were making a newsletter, this would have done just fine. Now, would someone lay up a whole glossy magazine on a setup like this? Probably not, I'd guess. I've misplaced my research on this topic, so take it with a grain of salt, but my understanding is that serious commercial publishing work was still being done either physically with paste up and cameras or on dedicated workstations up through at least the first few years of the 90s before stuff like Quark Express finally took over. But for a newsletter or a zine or something, yeah, no problem. And that makes a very good point, because in that context, considering how small this image would show up on the page, the poor quality of the scan really wouldn't have mattered, and neither would its lack of color. In fact, for this purpose, even grayscale was overkill once you think about how you would have printed this. I don't think it'll shock anyone if I say that color printing was not terribly widespread yet. I mean, it existed, but it was new enough in '91 that InfoWorld actually declared that the year of color printing on the desktop at last. But even then, what was their recommendation for an entry-level device? A dot matrix. Now, maybe you knew that impact printers could theoretically do color, but if you weren't around at the time, you might think it's just a funny novelty, a flash in the pan that nobody took seriously. But no, people really did it. When I was in elementary school, our computer lab was full of Apple II GSs with image writers attached, and I used those to make some of the worst color prints you've ever seen. My girlfriend also remembers having a color Panasonic in her house around the same time, so these were genuinely a thing, and they kinda had to be. Color inkjets had been invented, but they started at $1,000 and only went up. And the only other stuff available was like thermal wax printers that cost even more than that. The gold standards for consumer printing at this point in time were dot matrix and laserjet, which were both generally limited to black and white. And by that, I mean black and white. Nothing in between. No common print technology could actually deliver grayscale, unless you maybe worked for a magazine, and if you did, you'd have something nicer than the gray scanner for computer. For all the purposes that you might have bought this specific device for, you'd probably be most interested in the black and white modes. We haven't touched on those yet, and for some reason Picture Publisher doesn't support them, so let's go back to Paintbrush. Okay, back here on the stage of history, like I said, there's a bunch of color options here. We used 256 color or 8-bit mode before, but we can also do grayscale in 16 color or 4-bit mode. That's obviously very lossy. It would look like this, but you might actually have wanted that anyway. That knocks 2 bits off of every pixel, which trashes the quality, but it makes the picture about 30% smaller. And this brings us back to the size of scanned images, which was a real problem at the time. RAM constraints weren't the only issue we have to think about. Bitmaps were just huge, even compared to the mass storage devices of the time. Hard drives were getting bigger, but removable storage hadn't improved in years. Most people didn't have anything better than a 1.4 meg floppy disk, which is about 5 times smaller than a full-size scan. So if you didn't have a network, a magneto-optical drive, or a Bernoulli box, none of which were terribly common, your only option for extraditing your scans from their data island was to split them into multi-part archives and write each one to 5 or 6 disks. You might think that's an exaggeration, but it was really a thing, and I was still having to do it in the mid-90s. I really can't overstate how much USB changed everything. Now, to be clear, file compression did exist, and it did help, but it was still primitive. JPEG wouldn't exist for another year, and while Paintbrush does save compressed TIFFs, they use a very basic technique that only reduces the 8 megs to about 4. And you could swim upstream harder, for sure, but considering that you probably couldn't even view these images at full resolution, it was better to just not fight the feeling and work smaller. 300 dpi is a lot of Ds per eye. You could bump that down to 150 or even to 75, depending on what you intended to do with it. So for instance, let's scan our wolf again at 75 dpi. Now, that's still plenty legible, at least by the standards of this scanner. It fits much better on our screen, and it only takes up a couple hundred kilobytes. That's a solid trade. But we could also just make the scan physically smaller. Just like a modern machine, we can tell it to only capture part of a page. Now with a flatbed, this speeds things up since the head doesn't have to travel as far, and obviously a sheet feeder still has to pull the entire page through, so there's no speed improvement, but it can still be told to only transmit the part of the page you're interested in. Suppose, for instance, that we only had 4 megs of RAM and we wanted to scan our wolf in the best possible quality. Now, unfortunately, this scanner is pretty dumb, so if we just left the thing on defaults, it would actually scan him, spit him out, then just continue outputting empty pixels until the PC ran out of memory. But instead, if we hit the pre-scan button here, it'll do a quick low-resolution scan, and that gives us an image we can use to adjust the crop, and now we can do our full resolution scan. And now this file is only the size of the actual document. This will actually fit comfortably within 3 megabytes before compression. So these all help, but consider this scenario. You have exactly 8 megs of RAM, and you need a full page scan at the highest possible resolution. That's tough, but if color depth isn't critical, then you could reduce it to 4 bits per pixel. That would make the scan fit within 6 megs. It'll look crappy, but if that works, then it works. But in a lot of cases, the truth is, you don't really need any color depth at all, and that makes things much easier. If we select black and white, this drops the color depth to only 1 bit per pixel, and now a whole page will fit in a single megabyte. That's what we want to hear, so let's just see what that looks like. Yeah, that would be the problem with 1-bit color. Again, black and white is literal here. Every pixel is either on or off. But this is still far from useless, and it's actually very helpful in some cases. 1-bit color is actually still being used in some applications, particularly fax machines, and that's possibly partly because of this property. I mean, it definitely originated with technological constraints. Fax machines were very early imaging devices with very little transmission bandwidth at the outset. 1-bit images are easy to digitize, they're very small, and they compress even smaller with very primitive algorithms. A 1 megabyte bitmap can be crushed into 60 kilobytes or even less with basic run length encoding. You can send that over a very slow modem link in just a minute or two, and you can fit 20 pages that size on a single floppy disk. So it was definitely necessary in the early days, but even as fax modems got much faster, there was no strong push that I'm aware of to increase their color depth. That's probably because 1-bit color is more or less ideal for business correspondence. Beyond just being good enough, it can even unintentionally pull a readable scan out of an otherwise illegible document. For instance, I scanned this notebook page in grayscale, and my handwriting is visible, to be sure, but it's not tremendously readable. Now let's see it in 1-bit. That's a bit easier to make out, right? With 1-bit color, you pick a pivot or threshold. Everything darker than that becomes black, and everything lighter becomes white. Essentially, it has infinite contrast, famously a desirable thing for text, handwriting, and line art diagrams. So it definitely has its uses, but all the same, even businesses need to send photos sometimes, and this just won't fly. I mean, we can sorta, kinda make out the shape of our wolf, but all of his details are lost in these great big islands of inky black. We need at least a little more detail here, and that brings us to the final feature of this scanner, the halftone mode. It turns this into this. It's still not a photo, but obviously it's a lot more legible, and it still fits inside less than 100 kilobytes. That's pretty impressive. But it's not a very computery way to do it. Halftones are an ancient technique that originated in the newspaper business. Newspapers are also stark black and white, so when they started printing photos, they needed a way to solve the same problem we have here, how to make a legible picture with just one color. Halftoning reduces a photo to a grid of dots of varying sizes, which our eyes perceive as continuous tones from a distance. In computing, we have a similar thing, but we call it dithering. It comes in many forms, but most of us are familiar with the error diffusion method, which looks like this. It's kind of the most iconic look of the 80s and 90s, and also most of the reason that the Mac could manage legible photos at all before it got color in 1987. Both techniques solve the same problem, but with totally different approaches. In halftoning, the dots are aligned to a strict grid, and they grow and shrink to create different apparent shades. Dithering, on the other hand, is a dense mathematical process that basically diffuses the energy of an image across its area. It's something you can only really do on a computer, whereas halftoning was originally a physical process, achieved through some arcane summoning ritual involving perforated plastic sheets. I would say dithering generally produces a better image if you can do it though, so it surprised me to learn that at the time this scanner was sold, it wasn't uncommon to use newspaper-style halftones when printing digital images. This must have fallen out of favor before I started using printers because I don't remember it ever showing up as an option. And I've tried reading into the pros and cons, but I admit I don't fully get it. Maybe it was computationally simpler, or maybe, once again, it just came down to file sizes. If I dither our wolf and save him as a TIFF with contemporary LZW compression, he takes up about 300 kilobytes. If I do the same thing in halftones, he's only about 100 kilobytes. That's a 60% improvement just by arranging the bits in a different order, so that may have been the argument. But the goal of pretty much all image capture at this time was to eventually print it, and I also get the impression that halftones may have worked better on a typical consumer printer. But even if that's true, it doesn't explain why we'd pick it at scan time. However, this is addressed extensively in Chris Dickman's 1990 treatise, ScanJet Unlimited, a 260-page book dedicated to getting the best quality out of one specific scanner, the HP ScanJet Plus. Remember him? It's that guy again. This book is terrific. It's practical, it's to the point, it's full of scans and screenshots and short, pointed tutorials for dozens of popular applications of the time. It's an absolute time capsule of detailed info on early 90s digital imaging, and it also contains a pretty well-written section on theory. And it also suggests that at this time, at least some people thought of dithering as a subset of halftoning, which makes sense, but I never would have guessed it otherwise, and it would have made a lot of this stuff more confusing. So I couldn't have made this video without that book, needless to say. I actually bought a copy on eBay because even if I never need to refer to it again, I'll still have that fantastic cover art. But more to the point, Dickman's co-author, Steve Roth, dedicates many pages to the question of whether, how, when, and where to dither. There's even a section entitled Who Does the Halftone, which addresses the question of whether to dither your image when you scan it or right before you print it. Now, anyone watching this is probably shaking their head like, are you kidding? That's not a question. You scan at the highest possible resolution and color depth, you store the image that way, hopefully with lossless compression, and then you convert it to whatever format your printer needs right before you send it. I mean, duh. Who would do anything else? And per Roth, this was the gold standard in 1990 as well. Who Does the Halftone expounds at length on what a pickle you'll be in if you do anything else. You can have your scanner do the dithering, but then you'll be stuck with whatever it gives you. You can't adjust brightness or contrast after the fact. You can't retouch anything because the dithering won't match. You can't resize it arbitrarily because the dither will get all nonlinear and moiré. You can maybe double or halve the resolution, but anything else will just destroy it. And this only works with digital Bayer-style dithering. If you scanned in newspaper-style halftones at, say, 120 dpi, but you want to print on a 300 dpi printer, you're screwed. There's no fixing it. You have to go back and scan it again or accept horrible distortions to your image. There was no in between. And this was particularly bad if you were actually intending to formally publish your work. People in the print industry were apparently using things called image setters, which were capable of black and white prints at 2400 dpi. You'd still have to halftone your picture since they didn't do grays, but obviously you'd want to do it a little differently than if you were targeting a crappy laserjet. And yet you'd still want a proof on that laserjet. So you wouldn't want to dither at a factor of 2400 because it wouldn't integer scale to 300, and you wouldn't want to dither at 300 because it would look horrible on the image setter. Yeah, it all sucked. And on top of that, apparently, PostScript-based printers could actually accept a grayscale image and dither it internally, and that would be faster than sending it pre-dithered to those or any other type of printer. Why? I don't know, but the point is, just like now, you'd really prefer to make this decision at the last second. Scan in grayscale and do everything else later. But, he says, if you aren't targeting an actual commercial press, you probably shouldn't do that because once again, the files will just be too damn big. And that's all Roth wrote on the subject, but I actually have more to add, as if I haven't put a fine enough point on this already. Even if you talked yourself into doing it right, scanning in grayscale, dithering later, and even if your machine was enough of a beast to do it, it wasn't even a guaranteed W. I wouldn't have known this except that I found this thing recently. This is serendipity. I stumbled on it completely by accident 2 days ago. I had no idea anything like it existed, and it is incredibly relevant to this subject. This is the Intel Visual Edge, and it's a consumer version of what print professionals would call a RIP, or raster image processor. You remember the scanner I mentioned earlier that could be upgraded with a custom interface to make it talk to your PC faster? This is the other end of the chain. This has two cards. One plugs into an HP LaserJet 2, an extremely popular printer from the late 80s, and the other one plugs into your PC and gives it direct control over the print engine. But this isn't just meant to increase transfer speeds. It also contains its own hardware image processor that delivers a smoother, higher quality dither than the leading software packages of the era. Judging from the box scans, at least, apparently some popular apps would dither from a 4-bit source image, probably to save memory, and that produced a very uneven result. This looks like it works in 8-bit internally, and that produces a much smoother dither. It also leverages Intel's expanded memory card, the above board, to store the intermediate image, which was important because the LaserJet didn't have enough memory to buffer a bitmap and a high-quality font at the same time. Of course, this was expensive, it depended on other hardware, and it only worked with a single printer, so it was far from a universal option. So to sum up, if you are a professional with a monster workstation and specialized software, maybe you could use the modern workflow. But if you were a consumer, particularly one who would buy the cheapest scanner available, then you were going to have to make compromises. If you knew at the time you were scanning something that it was ultimately going to be printed on a crappy 120 DPI dot matrix, it behooved you to scan the image at 120 and let the scanner halftone it. It was probably faster than your PC, and it saves you the RAM and the disk space. It makes sense. But man, working this way sucks. And it's a little worse with this particular machine. ScanJet Unlimited is all about the HP ScanJet, and it has a whole appendix full of sample images for all the different dithering modes that scanner supported. Vertical, horizontal, error diffusion, different size halftones, all sorts of things. And indeed, PC Paintbrush seems to think this scanner supports all of those, but that's actually because it's using a ScanJet driver. This thing just keeps coming up. Don't worry, I'll tell you all about it later. As far as I can tell, this scanner pretends to support all these modes, but it only actually does the things it lists on the box. Grayscale, black and white, or halftones. No vertical or horizontal dither, no error diffusion, nothing else, just halftones. And that's not surprising. This being the cheapest scanner on the market, nobody's surprised that they'd cheap out on the algorithms. But let's follow that thought for a moment, because while we tend to assume the cheapest option is basically fraud nowadays, the meaning was very different back then. Nowadays, a cheap scanner looks like this. It's a big, empty plastic box with a sheet of glass glued to the top, and inside there's almost nothing. In one corner, there's a tiny motor with a couple thin plastic gears. That drives a belt, which drags the scan head along a shaft, which is the only piece of precision metal in the entire thing. The actual scanner consists of some LEDs, a single mirror, and a lens, behind which you find the image sensor. Somewhere in here is a chip that does all the actual thinking and talks to the computer, but I'd have to dig to find it because it's incredibly tiny. This thing has been cost engineered to hell and back. It weighs about a pound in total, and I could literally break it over my knee. Now let's look at the gray scanner for computer. This weighs about 10 pounds. The case is very thick plastic, and it has steel plates on the bottom and on the top. It's absolutely massive. But even that doesn't really tell the story, so let's open this thing up. It's held together by just 4 screws, all of which go into plastic. No machine threads here. All right, now we can pull off the plastic cover. It's a bit awkward. We have to pop this up, then slip this up and over it, and not rip off the control cable there. But there's its guts laid bare for everyone to see, and right away you can tell this may have been cheap, but the margins probably weren't huge because there's a lot going on in there. Let's lay out the basic principles. Down here we've got the imaging module. That contains a lens, and then the image sensor is back here. And then at the other end, we've got the document feeder. The paper slides in under this cover, and it passes over a glass plate called a platen. There's a fluorescent light shining up from underneath to illuminate the document, and then the spring-loaded lid has these plastic idlers that keep pressure against the rubber rollers on the bottom. Those are driven by a frankly beautiful drive system. These gears are also all plastic, but they're considerably heavier than the ones in a newer scanner. And of course, they've got this gorgeous belt drive system on here. I have to imagine that this whole assembly ate up like $40 to $60 of the final price tag because there's just so much to it. It's also captivating to look at. I love watching this thing run with the top off. But things get quite a bit weirder here in the middle. We've got these two mirrors. Those are actually slim little mirrors that are held in place by very crude little bent sheet metal tabs. And they're mounted at a very, very shallow angle. This is kind of confusing if you can't visualize the image path. So here's a side profile. The sliver of the document seen through the glass reflects down, bounces out, and then these mirrors basically just shift it up half an inch. I guess it's like, what, 12 millimeters, something like that. And that's so that it can enter the lens on the imager. These sensor modules, these were sold as off-the-shelf, complete optoelectronic units. I've seen devices just like this in many other scanners. So Scan Plus couldn't really do anything about the height of the lens, short of making the machine taller so that the platen could be higher up. But folding the image path like this let them use an off-the-shelf module without making the whole machine taller. It's pretty clever. Another odd thing, though, is this little metal semicircle here. I have no idea what that is. It sticks up nearly into the image path. It has 3 little holes in it, and the screw holes here are slotted so it can be adjusted side to side. So I don't think this is structural. It would have to be something related to the optics, a glare protector, a calibration aid at the factory, something incredibly obvious that I can't recognize because I'm looking at it from the wrong perspective. I have no idea. Give me your theories in the comments. Now, I'm going to open this up a little more in a moment, but I'd like to point out the lighting situation. The document is illuminated by a fluorescent tube. Now, that was quite common in 90s and 2000s scanners. They use LEDs nowadays, but it was all fluorescence back then. But there were always these angel hair thin CCFL tubes. This, on the other hand, is something you'd see in an under-cabinet light fixture. And I mean that literally. It's an F8T5 bulb, which are actually used under cabinets. It's absolutely gigantic, and I don't really know why it had to be. Maybe those tiny CCFLs just didn't exist yet, or maybe they weren't bright enough. I'm really not sure, but it is extremely funny looking. So to get this apart, we just take out 4 more screws on the bottom. Then 2 more screws on the top. Then we have to unclip the AC input, which is a gigantic pain in the ass. Disconnect the fluorescent tube and all these other cables. And now we should be able to lift off this entire assembly and take a look at the motherboard. And that is the name it deserves. If you had any doubt that this thing was worth its MSRP, well, maybe this won't convince you if you don't know what things still cost back then, but it's clearly more than a day's work, right? A lot of this stuff is just glue logic, but the core components here are an MCS51 compatible microcontroller, an I/O controller, 2 PROM chips, and then 2 SRAM chips that I think add up to about 16K of RAM. So it's no PC to be sure, but it is still a whole computer, and that was necessary because it not only has to control the scanning process and talk to the host system, but it also has to buffer every line of the image, since the PC won't always be ready to receive data when the scanner's ready to send it. Now, this is, to be clear, exactly how any modern device works, but nowadays it's all happening in 1 or 2 chips that cost like $5 a piece, and everything weighs so little that you can build it with a fraction the material. Everything was just much harder and heavier and more expensive in this era, and I imagine that Scan Plus spent a big chunk of that MSRP just on components and assembly. And that's the only reason that I really opened this thing up, just to make that point. But I have one other comment before we move on, because the power supply situation is interesting. There's obviously a discrete PSU over here. The 110 volts comes in here, gets converted to DC, feeds the motherboard. But that PSU doesn't run the fluorescent tube. That actually plugs in over here on the motherboard. Now, I don't know what voltage this tube runs at, but it's got to be at least 110, right? Now, the microcontroller needs to be able to switch that light on and off, and it does that with this relay here. Presumably it uses these semiconductors to control that. And there's also no ballast in here, so presumably all of this is also acting as an electronic starter, so it makes sense that it needs to be here, but it just seems spooky to put that much AC voltage 2 inches away from a bunch of logic chips. I mean, that's weird, right? I don't know. Anyway, let's put this thing back together. There we go. Assembled. I'll definitely put the screws in later. I would put in more effort, but you cannot imagine how hot this studio is. So we now have a pretty good picture of this specific scanner, what it does, how it does it, what it's like to use it, and how it's built. The workflow that we've seen and the results are a mix of surprisingly modern and shockingly outdated. So now we turn to the bigger picture. Was this ever state of the art? Is this just what scanners were like once upon a time? All monochrome, all sheet feeders, all crappy. When did high quality color flatbeds become the default? Well, I got answers to most of these questions. I'm not really sure on the quality point since I don't have sample files from contemporary scanners, but the rest I've got covered. My first question was, who invented the flatbed? And that actually got me thousands of very firm results, which seem trustworthy. The flatbed scanner was invented in 1975 by Ray Kurzweil for use in his reading machine. Yes, it's the same guy who started the synthesizer company, but the reading machine, as the name suggests, was actually a computer that helped people read books by speaking the words out loud. It was ostensibly the first practical application of text-to-speech and optical character recognition that didn't require specialized fonts, which is all absolutely fascinating and doesn't actually answer my question. None of these sources say what the flatbed displaced, if anything. And this is also a highly specialized application that wouldn't really reflect general computing, let alone the consumer market, which is what I'm concerned with. So he may have invented the flatbed, but not the computer scanner, because I know people were scanning pictures much earlier than that and that they did it very differently. For instance, just on Wikipedia, we can read that in 1973, a USC researcher who needed a good test picture for image processing experiments scanned in a Playboy magazine, producing an image that became known as Lena and would go on to be used as a standard test file for decades, despite being considered tasteless for much of that time. And the article also says that even further back in 1961, an MIT researcher facing the same need, for a study on dithering, as it turns out, decided to scan in another Playboy, Natch, and in both cases, they did it with drum scanners. Whenever I read about early computer imaging, I see these things mentioned, so I have to assume they were pretty common. The idea is you wrap a document around a drum, and it spins while an image sensor travels from one end to the other, producing basically a helical scan. It's kind of weird to think about, but this technique actually lasted decades, and at least some high-end film scanners still work this way, although the drum is now a clear glass tube that rotates at extremely high speeds, and they scan at 6,000 dpi or better. The quality is unmatched by anything else. The problem is that the film, or any other item, has to be wrapped around the drum, so it has to be a loose sheet. And indeed, in the history of the Lena photo, we learned that the researchers had to tear the page out of the magazine to scan it. This explains the connection to the reading machine. Countless sources state that the flatbed was so essential that Kurzweil had to invent it, but nobody ever actually says why, including his own website. You have to know the prevailing technology of the era to get why it mattered. Then it seems obvious. The whole point of the machine was to read books, but a drum scanner would have forced you to bandsaw the spine off. A flatbed lets you scan anything that can be pressed against the platen, and that's probably why it's become the dominant technology. But if people were scanning things all the way back in the 60s, then surely by 75, someone in the computer world would have noticed how inconvenient drum scanners were and maybe found inspiration in a nearby Xerox machine to build a better mousetrap. But even if they didn't, you'd think after Kurzweil's monumental ahead-of-its-time design that someone would go, okay, that reading machine is pretty cool, but what if we use that design to digitize images? And maybe they did. Maybe they didn't. Every source I can find goes dead silent on the topic for years afterwards, so it seems like nobody took Kurzweil's idea and ran with it. And that could make sense, because if scanning took up way too much space in '91, imagine how impractical it would have been in the late 70s. But I'm still not totally sure, because in 1981, Computer World wrote about an early digital fax system, and in the article, they just casually dropped the phrase flatbed scanning with no explanation. They don't describe the machine in any detail, so clearly they expected the average reader to know what that meant. Now, maybe they figured people would equate it to the well-known Xerox machines, or perhaps there was some prior art. On the other hand, I found a USGS report from January '85 which describes several common scanner designs in great detail, and they also mention a flatbed, but it's completely backwards. It holds the paper stationary and moves a scanner head over the top. So maybe Computer World was describing something like that. It's hard to say. At this point, I tried looking for a Contemporary Computer Chronicles episode, since that's always a great resource, and sure enough, they did a whole episode on scanners in 1991. As you can imagine, it's a real gold mine. It even starts out with Stuart Chaffee showing us a scanner mouse. I thought I was the first person to cover those.
This looks like a mouse, but actually it's also a scanner. It's the PageBrush Professional Scanner for mouse systems. And what's unique about this scanner is you can scan across, come down, come back again, and it automatically stitches together the final image for you. Now, you may not need a scanner quite as powerful as this one, but with everyone doing desktop publishing, the increasing emphasis on the graphic display of information, it seems everyone these days wants to get pictures into their computers. And that, of course, means a scanner. Today, we take a look at the latest technology in scanners on this edition of the Computer Chronicles.
Throughout the show, they demonstrate various kinds of alien contraption. There's a scanner that's built like a copy stand, for instance, that mounts a high-resolution camera above a document. Nowadays, this is used for low-vision assistance devices and handmade rigs for digitizing books for the Internet Archive, but I had no idea it was a thing back then. We also see one of those palm scanners I mentioned earlier, which you drag across the surface to copy a narrow swath out of a document. If you want a whole page, you have to do 2 passes, then join them in an image editor, which is incredibly inconvenient, and I have no idea why these were made or why they were popular. Oh, right, because they were super cheap. It seems like this category only lasted like 4 or 5 years in the market. They also have another variety of inverted flatbed on display here. The document is mounted on a sliding table that moves underneath a stationary head, yet another twist on the flatbed. And all of this suggests that the industry was just throwing spaghetti at the wall and nothing was set in stone yet. But I don't think that's actually true, because as all this is going on, modern style flatbeds are all over the place in almost every scene, and nobody treats them as remarkable. So I think all these other designs were actually novelties, and as far as I can tell, flatbeds go right back to the beginning of the market. I put my nose to the grindstone. I used all the resources I have access to at the moment, and I believe I figured out where scanners began. The earliest mention that I've been able to find is from 1984. Before that point, every hit I get is for a radio scanner or a barcode scanner. But in that year, a company called Datacopy announced their Model 700, which looks exactly like a modern scanner and appears to operate exactly the same way. Now, I can't be 100% sure on the timeline here because of the way magazine schedules worked, but it seems this wasn't alone. By the time it hit the market in 1985, it was accompanied by a very similar machine from a company called Laserfax, but I can't find any mention of them in '84. So I think the Datacopy was announced first. But regardless of which one is patient zero, this seems to be ground zero for the whole market. I'm certain there was prior art. I'm positive I've seen much older devices that could more or less be called scanners, but this was clearly the watershed moment. And you might think, if you haven't researched this particular industry in depth, that it's not as simple as flipping through magazines and looking for a headline that says, "Hey everyone, the state of computing just changed. Today's the day. Scanners didn't exist, and now they do." But as it turns out, this happened all the time. People didn't grant celebrity to the PC or the Mac or Windows 95 in retrospect. They were plastered on magazine covers the moment they were announced. People knew what they were witnessing as it happened. And sure enough, Popular Computing ran an article in mid-'85 with a great big hero image called Image Processing. The Computer Becomes a Copier, which treats the subject as a total novelty and describes the concept of digitized images as a new and growing trend before detailing all the ways you could now go about it. And clearly this was not yet solidified. The first product they mention is a thing called the ThunderScan, a gadget that replaced the head on a dot matrix printer and scanned documents one agonizing stripe at a time. I've heard the results were not fantastic. There were also copy stands, which put a tiny scanner head on a kind of drafting machine that let you scan printed text one line at a time by manually moving the head. I bet there wasn't a secretary alive that would rather do that than just retype the damn thing, since it'd probably have fewer errors anyway. They also describe what we'd now call a capture card, which let you digitize images from a video camera, and those are indeed quite ancient. I did a video on this one about 50 years ago when I started my channel. This worked on an original IBM PC. It ran under DOS 2.0, and it very, very slowly captured very crisp 1-bit video images. Delightful little thing. And let's not forget, of course, the constant mentions of optical character recognition. I can't overstate how popular this was. In fact, a year later, PC Magazine remarked that of the many scanners that apparently appeared in '85, a good chunk were incapable of reading graphics at all. They scanned the page like any other machine, but only delivered digitized text to the PC. And that makes perfect sense, once again, because of the memory problem. They were doing the OCR internally in the scanner, so the PC didn't have to buffer the whole page at high resolution before it could convert it. Oh, and they also mentioned that the only scanner that could do both tasks in '85 was the Datacopy 700. If you have one of those, please send it to me. But going back to '85, tucked in between all this thrown spaghetti is one paragraph entitled Flatbed Scanners, and it does describe the concept as if it was brand new. It details exactly how these machines were laid out as if for someone who's never seen one before, and it establishes their primary advantage, that you can scan books without unbinding them. It also says that there were all of 2 devices of this design, the Datacopy and the LaserFax. So I seem to have independent confirmation that these were the beginning of the market, but it was a spark that caught fast. By '86, magazines were doing whole roundups of scanners with dozens of models. Although curiously, very few mimicked the Datacopy. I assumed it would get extensively cloned, but it seems to have taken a year or two for that to happen. Everything in this 1986 article seems to be a sheet feeder design. By '87, however, there were so many scanners that PC Magazine had to dedicate half of their desktop publishing special just to reviewing them, and flatbeds were now appearing in great quantity. There was the Howtech ScanMaster, the Microtech MSF 300C, the HP ScanJet. Can we recognize that name? No, that must be a coincidence. Just 2 years after its inception, the market had heated up so fast that everyone was jumping in, trying everything and offering anything. PC Magazine had a sidebar about ultra high-end scanners that could do 1,000 DPI and better and cost nearly $100,000. Even IBM stuck their toes in the water. This is how I found out that they had ever made flatbed scanners, by the way, and thus how I learned about the fantastically ugly IdeaScan 2000. You could defend this thing if you want, I suppose, but it's your money. But alongside all those flatbeds were even more sheet-fed machines. And as it turns out, an awful lot still had to be fed one sheet at a time. ADFs were not really a thing yet. Now this is strange to me because if they weren't automated, why were so many people buying them? I mean, without the automation, a flatbed was no harder to use and a lot more flexible. So what was the point? Well, InfoWorld summed it up: cost. At least in 1988, they were 20 to 25% cheaper on average than a flatbed. Now, I don't know why this would be. I know how both designs are built internally. It doesn't really seem like a flatbed would be that much more complex, so my guess is that moving the head instead of the paper demands higher precision. So one question is answered anyway. Sheet feeders were never state-of-the-art, but they were once quite common. Thus, the gray scanner for computer seems to have simply been tremendously outdated for its era. And I wouldn't be surprised to learn that it's actually a design from '86 or '87 that ScanJet Plus bought and continued producing, since there weren't many other options for competing in the rapidly consolidating market. Going back to the sheet feeders though, I'm still kind of surprised that ADFs were so rare given how useful they are. I guess the technology for the automated hopper just hadn't yet been commoditized, but it must have happened pretty soon after, because by 1989, the modern hybrid ADF design became extremely widespread. Every flatbed in that year's scanner roundup listed an auto document feeder as an option, although for some reason the Canon IX30 was the only one they photographed with it installed. It also mentions that the IX30's scan engine was also used in the HP ScanJet Plus. This thing, it just keeps coming up. What is it?
Welcome to the Computer Chronicles. I'm Stuart Chaffee, and with me this week is Heidi Roizen, president of Teamaker Software. Heidi, we have here the HP ScanJet Plus scanner. It's amazing to think it was only 4 years ago, actually, the original HP ScanJet came out, which really kind of launched the scanner business.
I would have called the Datacopy 700 the Benz patent motor wagon of the industry if anyone had asked me, but if Stuart is to be believed, that label really belongs to the HP ScanJet. That makes the ScanJet Plus the Model T. Not the first, but cheap, beloved, and it only came in black. Monochrome, that is. Both the ScanJet and the Plus were grayscale only, but apparently the Plus improved on its older brother in every way because the praise for this thing was uncommonly ubiquitous. PC Magazine covered it in their August '91 roundup despite it being, I think, 2 years old already, and glowing recommendation feels like an understatement. They open with this. Some products do wonderful things, but make your life miserable in the process. Then there are those like the HP ScanJet Plus, which give you all the power with none of the headaches. They praise the configuration software and the machine's toolless nature, they love its quality and its speed, and they conclude that it's the grayscale scanner to buy. The Plus got reviewed year after year like this. It was a pivot, a benchmark for other machines. I mean, hell, it got its own whole book, right? So it's no surprise that a smaller manufacturer would emulate it. For all I know, the big manufacturers did. In the early days of computing, de facto standards were all over the place. Video cards were EGA or VGA compatible, modems were Hayes compatible, floppy drives were Shugart compatible, and so on. None of these were official open specs, but whenever a company produced a seminal product that sold in mass quantity and defined new capabilities for the platform, it would get reverse engineered and enshrined as a standard that tons of companies mimicked, big or small. Making your scanner ScanJet compatible meant that it would work with most of software, a real advantage in an era before hardware abstraction layers. The ScanJet Plus was apparently ubiquitous enough to become one of these standards, and that's probably because it was extremely cheap for its performance level. Not that it was cheap. The scanner itself cost $1,000 without the document feeder or the interface kit. That was an extra $500. And that confused me because, wait, the interface kit, isn't that the card? Don't you need that to use the scanner? Seems like a lot of money, and why would it be optional? What are you going to do without it? Well, as it turns out, I was wrong earlier. Boy, that's never happened before. I'm pretty sure that interface package is actually a weird euphemism for the software, and the ScanJet didn't actually need an interface card. Here's a picture of the back of a ScanJet Plus. You see that port labeled parallel IF? I was pretty sure they didn't mean a PC parallel port, but I think they actually do. PC Magazine says the main difference between the ScanJet and the iX30 was that Canon's product used a SCSI interface while HP used a bidirectional parallel port. That's what IBM called the slightly upgraded printer port they added to the PS2 lineup, and I had a hard time getting firm info on that, but it seems like the upgrade bumped the port speed by about 3 times to around 150 kilobytes per second. This explains how the ScanJet could have been the fastest scanner in PC Magazine's entire roundup, despite me spending 10 minutes earlier declaring that you could never run a scanner over the parallel port at any kind of speed. Yeah, no, I love going 25 years thinking I know what something is before finding out it's actually 4 different things. Sure makes me look smart when I say stuff. In conclusion, the ScanJet Plus was the gold standard of scanning for years, if you wanted grayscale, which was such a widespread desire that the roundup in question only covers grayscale. But what about color? When did that come into the picture? My initial guess was that grayscale was never state-of-the-art, and that may surprise you because it seems like a natural step. You start monochrome, then upgrade to color, right? It happened with film, it happened with TV, it happens with every imaging technology. Or at least, it seems that way. Like, okay, I'll give you this. It does seem like a natural step. This is a very early consumer video camera from about 1978. It was made by RCA, and it's so old that it doesn't even use a solid-state imager. It's built around a thing called a video tube, one of these. It's sort of like a CRT that runs in reverse. Okay, well, it literally is a CRT, but it captures images instead of producing them. This was the state of the art for several decades, and this camera is in fact black and white. It can't do color at all because its tube isn't color. But that was just a matter of cost in 1978. On the other hand, there was a time when all video cameras were like this. In 1952, they simply hadn't figured out how to put color in the tubes, just as in 1912, nobody knew how to make color film. So it's easy to say that imaging technologies just start out black and white, then become color. It always goes that way, right? Well, not quite. It didn't go that way for CCDs. I'm not aware of any video camera with a solid-state monochrome sensor being sold to the general public. Except maybe the PXL 2000, but that was a toy, and I don't know for sure that the sensor was actually monochrome. Otherwise, though, the earliest models that I'm aware of were color. In fact, from what I've read, engineers had color sensors working in the 70s, years before anyone put one in a production camera. And I'd guess that that worked out due to the rapid pace of silicon technology. I mean, obviously, CCD manufacturers would have developed the professional imagers first, but once they had the lithography figured out for the broadcast grade chips, it was probably relatively easy to just cut the resolution in half, delete 50% of the photo sites, and churn out a cheaper consumer product which would get color essentially for free. And this had all already happened by the time the first scanners launched. The first consumer CCD cameras were sold in 1983, and they were nearly universal a couple years later. So why were they making monochrome sensors all the way in 1985? Well, I'm not sure, but I can guess that it has to do with the economics of linear CCDs. That's the type of imager that's used in scanners. Here's the one from the Epson I tore apart earlier for reference. Don't worry, they all look exactly the same. You can see the sensor is wide but very short. That's because it captures only a single line at a time, hence linear. It's 2600 pixels wide, but just 1 pixel tall. Now this approach is obviously only useful for scanners. Their subject stays perfectly still so they can capture the image slowly, line by line, unlike a normal camera which needs to capture the whole picture in one go. And of course, these are also useful in fax machines, which, as Wikipedia tells us, were the progenitors of scanners. Citation needed, but still, that's an interesting suggestion, right? And it's probably true. Do I know how the scanner was invented? No. Do I think that someone at Datacopy looked at a fax machine and said, hey, what if we plug that into a PC? Yes. With absolutely no proof. I just take it as read that that happened. Of course it did. Fax machines were everywhere, and countless nerds must have had this thought. Datacopy just made good on it. In fact, even though grayscale scanners were available on day one, there was actually an ultra low-end segment that quickly developed full of scanners that were limited to 1-bit color. And this is total speculation, but I would guess that you could probably buy 2/3 of a fax machine as a pre-built unit, right? Everything there, complete with a crappy digitizer. You were supposed to put it in a plastic case and put your own telephone front end on it. But these companies bought those and just stuck a parallel or SCSI interface on them instead and kept the crappy digitizer. Now, I can't prove any of the above, like I said, but let's just assume it's all true, that scanners in '85 were underdogs eating the scraps off the fax machine's table. It then makes sense that the only sensors they could get would be monochrome. But 2 years later, that wasn't true anymore. This was a major market, apparently hanging off the coattails of the desktop publishing explosion, which was valued by some sources at billions of dollars a year. With huge manufacturers like Hewlett-Packard in the game, surely they had the clout to get full-color sensors made, or maybe just make some themselves. But this never happened, because it didn't need to. I've been beating around the bush with regards to this last question because we all know the answer already. We know it because it's the funniest possible option. Color scanners have been around since day one. Of course they have. You knew that in your heart. Let's get real. By the time scanners existed, it wasn't 1952 or even 1978. Color was old hat. Everyone expected it. Nobody was going to go, well, guess it's just black and white. Maybe someday. That laser fax that supposedly came out alongside the Datacopy, its actual model name was the SpectraScan, and you can guess what that meant. It did full color scans at who knows what depth and resolution, but clearly grayscale was never actually state of the art. It just dominated the market for a while because it was a lot more practical. I mean, let's not even get hung up on the RAM issue again. Actually, yeah, let's do that. At only 8 bits per pixel, a color scan would have been 8 megs. Now, I don't know what you would have done with that in '85, so good luck there, but even 8 bits isn't all that useful in color. If you're going to bother wasting the memory and computational power, you really want a lot more. Ideally, 8 bits per channel, 24-bit color. That would produce a monstrous, terrifying 24 megabyte scan, and I don't think anything could have worked with that at the time, so color was of limited value. But even assuming that you had some $40,000 dreadnought workstation, color was also incredibly inconvenient to scan in the first place.
Joining us now to demonstrate 2 different types of scanners are Serge Timoshev of Logitech and also with us Larry Lunetta of AVR.
The basic element of a desktop scanner is the camera, and it's very much like the element you find in an everyday copying machine.
And what's the difference in a black and white scan and a color scan there, Larry?
Okay. A black and white scan takes the light as it comes off the image. A color scan uses a sequence of red, green, and blue filters to produce a 24-bit color image, much like a television uses a red, a green, and a blue gun.
Early scanners had to scan in 4 passes, switching color filters each time until the machine built up a full color image. 4, apparently, because in addition to red, green, and blue, they also did a black pass, presumably with no filter. Don't know why they needed that, but they did. And it means that they took upwards of 3 minutes to scan a single page. And notice, by the way, that clip was yet again from our 1991 Computer Chronicles episode. So this is how it was being done on day 1, and it's still how it was being done 6 years later. Apparently, not much effort was put into solving this problem, presumably because the people who needed color, enough to put up with 24 megabyte files, were also willing to wait. And this is yet another reason that people continued buying grayscale scanners. They were much faster. But the situation was about to improve. RAM and hard drive space were getting cheaper, and high-resolution GUIs were becoming more common. Manufacturers could see that color was about to become way more useful, so they set to work and found ways to make it practical. By late 91, you could buy single-pass color scanners, which, as the name suggests, could do a whole page at 600 dpi or more in full color in one 30-second scan. And while this would obviously become universal, 4 years later there were still advertisements hawking single-pass color scanners. I don't even know if the multipass ones existed anymore. I think the sting of those 3 and 4 minute scans just really stuck with people. So color scanning did become tolerable, but the solutions weren't what you'd think. And I say solutions because there were actually several different approaches. Epson's idea was to use 3 different light sources and put the color filters on those. Then they'd rapidly flicker between them as the head moved down the page. So basically it still did 3 passes, but it interleaved them, which saved a ton of time. HP, on the other hand, used a bizarre solution with a 3-line monochrome CCD and a set of what I believe were dichroic prisms that split the image into its color components and landed each one on a separate sensor. And that's actually better illustrated in that Tech Tangents video that I mentioned earlier, so check it out if you want to see more detail. It's pretty wacky. Man, the past was a wild place, right? Thank God all this trickery was only needed 30 years ago, and we've moved past it. No, we didn't. You knew that. I looked up a bunch of datasheets for modern sensors, and most of them seem to be a trilinear design. That's a single module that contains several individual single-line sensors. That's a lot like HP's first color approach, except each one has a single colored filter over its entire length. You have a red stripe, a green stripe, and a blue stripe, all stacked vertically and struck with the same full color image. I put the one from that Epson that I tore apart under a microscope, and you can clearly see this. It seems to have 2 of each line, for some reason, but the principle is the same. It's the HP approach, just inverted. Why split the image with expensive prisms when you could just colorize the 3 sensors? It's honestly kind of surprising nobody thought to try it sooner. So in the end, HP's approach basically won, except where Epson's did. I don't know exactly how their first one-pass scanner worked. Did it have 3 fluorescent tubes that traveled with the scanning head, or did they stay in place and bounce the light around? I don't know, but I'm sure it was complicated, which would have kept it from becoming a cheap solution. But with RGB LEDs being cheap and plentiful these days, there are in fact tons of scanners that still use Epson's field sequential approach. Like this Epson, for instance. Flashing lights coming up in a second, by the way. There'll be a ding when they're over. This is a USB-powered scanner, and like many of those, it appears to use plain white LEDs. But if we shoot at a super high frame rate, we find out that it's actually rapidly strobing between red, green, and blue, exactly the same way they were doing it decades earlier. And that suggests that this actually still has a monochrome sensor, and I think a lot of scanners still do. Now, surely that's not necessary, right? Technology has certainly advanced to the point where we could put the filters directly on the CCD, but well, for one thing, many of these aren't CCDs anymore. There's something called a contact image sensor, or CIS, that I don't even understand. So I don't even know if you could do it with them, but even the trilinear ones seem overly complex. Why do this 3-stripe business? Why not just use a Bayer grid like a normal camera? Well, here's the thing. Given the option, no designer would ever use a Bayer filter, and whenever possible, they don't. You know how earlier I said that nobody ever sold a camera with a monochrome CCD to the general public? Yeah, that was pretty much a lie. They sold tons. This is just a small selection of my various 3-chip cameras. Every single camera on this table, which were sold to professionals, high-end amateurs, and just straight-up consumers, has not just one, but 3 monochrome CCDs. Well, a lot of them are probably CMOS, but who's counting? What I mean to say is that none of these cameras have Bayer filters on their sensors. Instead, each one has 3 separate sensors attached to a block of dichroic prisms that split up the image into its component colors and land each one on a different sensor. Is there an echo in here? Oh, right, this is exactly how I described HP's color scanner mechanism. They didn't invent a new way of doing things. They just adopted a long-standing practice that goes back to the beginnings of color television. This is how it was done in 1954 with the first color TV cameras, just using tubes instead of chips. And it's how it was done in 1983 with the first professional solid-state cameras. And it's still how it's done now because it's the only correct way to do it. We've never actually invented an image sensor that detects wavelengths of light. All imagers, solid state or otherwise, are actually monochrome. The camera in your phone is a black and white camera. It can only detect color because it has a Bayer grid, a tiny array of colored filters over the sensor that makes each light detector, or photosite, receive just one primary color. The Bayer grid was a brilliant invention. It allowed us to make tiny single image sensors that could detect full color, but they're intrinsically flawed. They sample multiple distinct points and merge them into a single finished pixel. That invariably introduces moiré and other aberrations that are impossible to fully correct. We've gotten very good at faking it with image processing, but it can never be fixed entirely. Using 3 separate sensors fixes it perfectly, however. All 3 components of each pixel are sampled at exactly the same spot, so the colors stack flawlessly with no moiré or aliasing. It's been the gold standard for professional imaging for nearly a century, and since it's a matter of physics, it will be for the rest of time. Unless Foveon somehow makes a comeback. The only reason we make single sensor cameras at all is due to cost. Well, and space. You couldn't exactly stuff a 3-chip camera into a smartphone, although if anyone does, let me know. But even if we aren't talking about something that small, 3 sensors just take up a lot of space. It's why nobody ever tried doing this with a digital SLR. Nobody at all ever tried this. Because that would just be silly. But scanners are in a unique position. No matter how time marches on, they still capture just one line at a time, so their sensors remain tiny and simple by modern standards. A 1200 dpi linear sensor only needs to be 10,000 dots wide. That's chump change. We put sensors with 6 million dots in a camera just for laughs. Adding 2 lines to bump that number to 30,000 costs nothing and doesn't really make it any bigger, so that's what they did. Your $90 flatbed scanner is therefore superior to any digital camera you've ever handled in terms of color fidelity. And yes, that includes this one. It's from 1995. All bets are off. So we now have the final piece of the puzzle. Grayscale was indeed never state-of-the-art. It was just the practical option for most people for the first few years of the technology. It was a heyday with a long tail though. Even though PC Magazine's August 91 issue said there were plenty of affordable color scanners on the market, they didn't actually cover any. That roundup only contained grayscale models, and it included a sidebar about how color just wasn't ready yet. They were pretty sure the hardware was mature, but the software wasn't quite there. And even in '94, almost 10 years after the first color scanners hit the market, they remarked that in the past, 24-bit scanners were expensive, limited, and difficult to use, implying those days had only just ended. And that same article opens with the observation that, until recently, few people had a PC that could even handle color scanning. So it's no surprise the machines weren't getting the attention they deserved. Now, leaps in PC performance in the early 90s made color scanning a lot more relevant, and indeed, they cover a bunch of color scanners in this issue, but even then, there were battles left to fight. Fortunately though, the software front wasn't one of them. As we saw earlier, scanners in '91 still required app-specific support, but that ended pretty quickly. In early '92, a number of manufacturers banded together to develop a cross-platform scanning API called Twain, and it was rapidly adopted. From all reports, it basically fixed the compatibility situation overnight, and I believe it's still used heavily today. But on the other hand, there were a lot of really crappy scanners on the market at this point. You know a technology is truly mature when the market's full of unremarkable filler, like the Computer Friends AV660, a repackaged Toshiba with completely middling performance. This was actually a common theme though. All the way back in '89, PC Magazine remarked that the majority of scanners were based on a handful of engines and were functionally identical. At least one reviewer complained that this made the roundups tough, since they would try to compare 15 scanners only to find out that 8 were literally the same unit. I wouldn't be surprised if it was the same story with my crappy old Agfa. It was probably somebody's cast-off D-tier product rebranded by a company that was struggling to fill store shelves. But even those middling scanners usually did single-pass color, which is interesting because it wasn't yet universal. I reacted with shock earlier at one pass still being a selling point in 1995 because I assumed that it took off immediately and just revamped the whole market. But I took a second look and I learned that while it did become very popular, it didn't replace the multipass approach right away. By 1994, multipass scanners were bit players. Single-pass designs dominated the market, but for instance, all the way up in 1995, a 3-pass scanner managed to win PC Magazine's roundup, at least in the quality department. At 3.5 minutes per scan, they still found it hard to recommend fully, but the point is, this approach still had some relevancy 4 years after it had seemingly been made obsolete. But I'm pretty sure that's the cutoff. InfoWorld mentions the concept of 3-pass scanning in 1996, but they don't actually have any examples that year, and I haven't been able to find any newer ones. It seems like I was born just late enough to miss this particular misery. Sorry to all the people who weren't. Sounds like a skill issue. Multipass scanning actually had one last hurrah after 95, but for a totally different purpose. 5 years later, in 2000, Canon produced at least 2 scanners using a system called Veros. They had 600 dpi sensors, but they performed 2 passes and physically shifted the sensor in between to achieve a 1200 dpi result. Why they did this, I have no idea. Epson sold a 1200 dpi scanner the same year that did a better job in a single pass and cost less. And it appears that only 2 Veros scanners were ever sold, so it seems like they quickly abandoned this in favor of conventional approaches. And that appears to have been the end of the multipass era, at least in the general market. To be clear though, while I'm making a lot of noise about this, it's only because I never knew it happened. But I doubt most people did even at the time. It probably wouldn't have really bothered many consumers. If you're using a scanner for work, processing dozens of documents a day, then yeah, 3-minute scan is going to bug the hell out of you. But if you're just scanning the occasional family photo or whatever, you're not going to care that much. 30 seconds, 3 minutes, 30 minutes. It doesn't really matter as long as the thing's cheap and works. So to restate my thesis, the scanner, as we know it, the ubiquitous color flatbed, existed from day one. Speed, cost, size, and resolution have all improved massively, and that made them more accessible and convenient. But functionally, there's no real difference between a LaserFax SpectraScan and an Epson Perfection. And it's strange to see an industry just pop into existence like that. Scanners simply appeared 40 years ago, fully formed. The manufacturers stuck the landing instantly, and they then had to spend 10 years working way below their skill level simply because nobody was ready for their strongest potions. That's weird, right? It would be like if Sony developed a portable CD player in 1974, then had to wait a decade before anyone wanted to buy it. But it also explains why this is such a solved problem. The bit I was doing earlier about scanners being boring wasn't strictly true. I mean, hell, I've made at least 3 different videos about weird scanners, depending on how you count it. And a friend of mine actually has one of those film drum scanners, and trust me, it's exciting.
If I click this, hell yeah. You can get a scanner with turn signals.
I'm sure there's other exceptions out there. There probably is stuff worth talking about, but the point is, when you say scanner, virtually everyone imagines the same thing, and that thing has been mature for as long as most people can remember because vendors have been laser focused on that one approach ever since it was first dreamed up 4 decades ago. That's pretty cool if you ask me. And it also made this video a lot easier to write because I could just stop in 1985 and say, and the rest was history. And as far as I know, it was. But I'd still like to address some errata. Errata? Never sure how to pronounce that word. I frankly suspect that there's some crucial information missing from this timeline. If I were to put in a few dozen hours at the library, flipping through dead trees that nobody's digitized, I suspect I'd find that Datacopy did not originate the idea of the flatbed PC scanner. For all the hot air I spent on it, it just seems too complete, too finished for me to buy it as a first try, especially with all the magazines consistently saying flatbed as if it was a well-established term way back into the early 80s. I feel like there was something before this that I've failed to discover. And probably, whatever it was, it came from the industrial sector. There were scanners used by magazines and newspapers and whatnot way before consumers had access to them. And it's entirely possible data copy was inspired by those. I'm not sure how to find out though. I've seen bits and pieces about that field and it looks intimidating. I believe there were whole dedicated publishing workstations in the 80s that took up half a room and did stuff that wouldn't be possible on a PC until the late 90s. Gigantic full-color digital presses and lots of other zany instruments, but it's all completely beyond me. I don't even know where to start. I'd have to find some trade journals and maybe someday I will, but as far as the consumer market is concerned, I think I've answered this question to my own satisfaction. I hope you found it satisfying too. I know that was a tremendous amount of talking with very little doing, but once in a while I just feel like the research is the point. The gray scanner for computer is, like many things I try to cover, somewhere between a prop and a writing prompt. It's not all that interesting in itself, but it raises too many questions that it can't answer on its own. Looking up this device gets you very little information, but it leads you to many other stories, which are much more interesting. Thanks to this confusing object, I now know an enormous number of things about scanners that I otherwise never would have. And so do you. Good luck with that. I'm sure it'll help you in life. But in any case, thank you so much for watching. This video took an enormous amount of work to put together and I had to rewrite and reshoot it multiple times to get it right, so I really appreciate you sticking around for the whole thing. If you enjoyed this and it's your first time on my channel, maybe consider subscribing. I'd like to think most of my stuff is a bit less dry than this. It's usually at least a little bit wet. Remember to turn on notifications too if you want to get notifications when I release things, but if you really liked this, then consider supporting me on Patreon like these folks are doing. This is my full-time job, and I don't take sponsorships, so they're paying for my groceries and bills and rent, and that's the only reason that I can do stuff like this. It took me 3 or 4 weeks to develop this video with several false starts, but if I was doing anything else, it would have taken 3 months. So I really appreciate the support of all my patrons because I just couldn't do this without their support. Thank you all so much. And everyone else, thanks for watching. Oh, and to my fellow queers, happy Pride Month.